My topic for this project is radiological practice, which is also known as nuclear medicine. Nuclear medicine includes working with and around nuclear substances, which is, for example, there are machinery like MRIs, CT, PET scans, and also bone scanners. This also includes injections which contain nuclear dyes which help locate infected or broken areas so the nuclear medicine can spot the areas. The historical development of this topic started back in the late 1800s. William Crook invented a cathode ray which held a thick piece of black paper with electricity, and a fluorescent light appealed within the tube. Also in 1903, Marie Curie and her daughter Irene Curie were involved within this profession and new developments. Right now with nuclear medicine, the current usages for this substance is to help diagnose and to see the main functions within the body. This has also been the main structure of medicine since the early 2000s. Another topic for this is for in the future, nuclear medicine professionals will be able to utilize AI through imaging to help diagnose new diseases and infections from radiology. The chemistry background includes radiopharmaceuticals and radioactive tracers for identifying diseases and illnesses within the body. For example, alpha rays are a consistent of 2 protons and 2 neutrons bonded together into a particle identical to a helium -4 nucleus, and this has a +2 charge. This is used to destroy cancer cells, which is also a high energy released from this radioactive substance. And then we have beta rays, which consist of fast-moving electron emissions by radioactive decay. This can have a positive and negative charge. Beta radiation can also include lead-210, bismuth-214, and thallium-206. And then there are gamma rays, and this is a form of electromagnetic radiation. This is the most harmful external radiation. This is a very high energy radiation, which means this has enough energy to remove an electron from an atom or molecule, and a lot of exposure can cause cancer with this radiation. And then with some scientific rules, there are $15 nationally that have contributed to the science of nuclear medicine since 2010, and one is also from Ohio, and he has studied in different areas in Columbus and started at the university hospitals. Government regulations include needing precise training and degree to be able to be near any nuclear substance or work with it. FDA regulations and guidelines explain more of this topic. And then with positive and negative impacts, some of the positives are resulting from testings, treatment, and diagnoses. All of these help with knowing what's wrong just from this substance. And then some of the negatives are huge expense for medical usages because of how expensive it is to be able to get this nuclear substance, and also just for testing it is very expensive. And then exposure rates are very high when in contact. Like when I said gamma rays are a possibility to getting cancer from using this radiation. And in conclusion, nuclear medicine has a positive and negative aspect, as well as many people who are interested in this field of study. There is a very high demand. Since the early 1800s, nuclear medicine started in a very small beam of light through a cathode ray, and now has turned people's lives around for the better because of the testing and treatment that has been given from nuclear productions.